Now, how can we make use of this alpha beta equation? That is, how can we solve some problem based on this alpha and beta equations? So let's see some problems. Let's see. They said given that let's just pick an example randomly. 3x squared plus 5x plus 6 is equal to 0. They said find from figure 1 alpha plus beta, from figure 2 alpha beta, from figure 3. Let's just complicate the issue. Anyhow they put it, it's still simple and straightforward. Alpha plus beta cube. Let's say we have alpha plus beta and alpha beta. Let's say we have to find all this. So how are we going to go about that? You just have to mark, we have already derived the formula for whenever we have to look for alpha plus beta. We said alpha plus beta is always minus b over a. It's similar to the way on how we can find a, b, and c on the quadratic equations. And we have gotten that alpha beta is also c over a. Now, I told you the first thing that you need to do, go back to your problem and evaluate the value of your a, b, and c. So from the problem, we have 3x squared plus 5x plus 6 is equal to 0. Now, the same method. Here, my a is going to be 3, my b is going to be 5, and my c is going to be 6. Just like exactly how we pick them when we are solving quadratic using formula. Now, the first question I was asked to find alpha plus beta. Now, alpha plus beta I know is minus b over a. Now, I can have this one to be minus. So my b here is 5. We can have 5 over, and our a is what? Our a is 3. That's 5. You can see that it's simple and straightforward. Alpha plus beta is minus b over a. This minus, we have it there. Assuming if this b also contain minus, we just see minus times minus, and that's going to be plus. But now we are looking at is only b have a positive numbers. We have minus 5 all divided by our b is 3. That's why we have minus 5 over 3. Now the second problem, they said to find the value of alpha beta. So since we have alpha beta, we can make use of the formula. Alpha beta is c over a, right? So our c from here is 6, and our a, what's our a here? Our a here is 3. Now, how many 3 can we get in 6? We are going to have 2. You can see that it's straightforward. Now, that is alpha plus beta is c over a. For my equation, I have my c to be 6, and I have my a to be 3. So 6 over 3. How many 3 can we get in 6? Of course, I can have this one to be 2. Now, the next problem, we are asked to find alpha plus beta all cube. So here, you need to stress yourself, meaning we are going to multiply alpha beta in 3 times. That is alpha beta times alpha beta times alpha beta. Now, from here, from second problem, we got our alpha beta to be 2 now. So that means this simply means 2 cube. So what is 2 cube? Can we say 6? No, because if I have 2 cube, it's not 2 plus 2 plus 2. As well, it's not 2 times 3. 2 cube, it simply means we have to multiply 2 in 3 times. That is 2 times 2 times 2. So 2 times 2, we are going to have 4. 4 times 2, we are going to have 8. So that means our alpha beta all cube is going to be equal to 8. Now, the next problem, we have to find alpha plus beta multiplied by alpha beta. So this one is just straightforward examples. In the first question, we have gotten our alpha plus beta. And in the second one, we have our alpha beta. Can we just see? So we go 4. Our alpha plus beta, we have that one to be minus 5 over 3. And we have our alpha beta to be 2. Now, the question says to find alpha plus beta and alpha beta. Straightforward. You just go back to alpha plus beta. Alpha plus beta is minus 5 over 3. Just substitute. Minus 5 over 3 multiplied by alpha beta is 2. So I can have this one to be 2. Let's assume that maybe what I have for alpha beta is also fractions. So we do it the same way. I will just have minus 5 over 3. Let's say this one is 2 over 5, for example. It's going to be minus 5 over 3 times 2 over 5. I'll just multiply numerator by numerator as well, denominator by denominator. So now, minus 5, or I can even say 2 over 1, minus 5 times 2, we are going to have minus 10. 3 times 1, we are going to have 3. Then you can divide this fraction. 3 in 10, we have 3 whole number, 1 over 3. So you can see that how to find either alpha plus beta, or alpha beta or cube is straightforward. So there's another way you may be asked to find either alpha square plus beta square, or alpha square minus beta square, or alpha beta or square. I will derive all of them so that you can know how to mix use of them one after the other. Let's look at how can we derive alpha square plus beta square, because that one is not straightforward. When we are asked to find alpha square plus beta square, it doesn't mean that we have to square whatever we have for the alpha plus beta. For example, how can we derive alpha square plus beta square? So the normally write this one as alpha plus beta whole square minus 2 alpha. So how can we derive this? So let's see. We take it from these expansions, alpha plus beta, this is a simple expansion. Using the first one to multiply the 2, right? Using the second one to just like how we normally expand simple terms. Now, here I can have this one to be alpha times alpha, that's going to be alpha squared. So here I can have this one to be, what is what I have, I'm trying to prove. We have alpha squared plus beta squared. Well, let's start from here to make it easier. I know that alpha plus beta all square, it simply means alpha plus beta and alpha plus beta. So I want to expand this now. So now let's expand this one. So alpha times alpha, that's going to be alpha squared. Alpha times beta, that's going to be alpha beta. Beta times alpha, that's going to be alpha beta. Beta times beta, that's going to be beta squared. You can see we just expand the simple expansions. Alpha times alpha, we have alpha squared. Alpha times beta, we are going to have alpha beta. Beta times alpha, we are going to have alpha beta. Beta times beta, we are going to have beta squared. So now I can have this to be alpha plus beta all squared is equal to alpha squared plus beta squared. Alpha beta plus alpha beta. Of course, we are going to have 2 alpha beta, just like we are adding 2 terms together. You know, this one means 1 alpha beta plus 1 alpha beta. So if I add them, we have 2 alpha beta. Recall, you know, what we are looking for is alpha square plus beta square. So now I can collect the like terms to make this one the subject of the formula, because what I'm looking for is alpha square plus beta squared. So meaning we can have this one to be alpha plus beta all squared. This is positive. When the positive comes to this side, it's going to become minus 2 alpha beta is equal to alpha square plus beta square. You can see. So whenever we need our alpha square plus beta square, we normally apply alpha plus beta all squared minus 2 alpha beta. So that's another thing you have to take note on. So when you are asked to find alpha square plus beta, it doesn't mean that you have to square whatever value you have for your alpha plus beta. We have to use these expressions. Whenever we are asked to find alpha plus beta all squared, alpha square plus beta squared, it simply means alpha plus beta all squared minus 2 alpha beta. Even, okay, for example, let's say we have a problem like this. It's a given that let's pick an example. Let's x squared plus 5s plus 6, or let's say plus 6 is equal to 0, for example. They say find Roman figure 1, or let's say minus. So to that it will be more interesting. Let's say we have to find alpha plus beta, Roman 2 alpha beta, Roman 3 1 over alpha plus 1 over beta, Roman 4. Let's say we have to find alpha over beta plus beta over alpha. So they might give a problem in any forms. Just know the origin of it. The most important is alpha plus beta as well, and alpha beta. Now from here, let's first evaluate out our values, our 3 values. We want to evaluate out the 3. We want to evaluate our A, our B, as well our C. So from here, just as usual, you know, what we have here is 1, right? So this is my A. I can pick out my B here. as well. I can pick out my C here. So that means my A here is equal to 1, right? My B here is equal to 5. At the same time, my C here is equal to minus 6. So we have gotten out all the 3 parameters that we need. Our A is 1, our B is 5 as well. Our C is minus 6. So the first problem, we have to find alpha plus beta. We derive that one. So we know that alpha plus beta is always minus B over A. So from here, if I check my A and my B here is 5, right? That is a minus 5 over my A is 1. Of course, we can have this one to just be minus 5. So second one, we have to find alpha beta. We derive that one to that. Alpha beta is always the same thing as a C over A. But if you look at C here, it has minus. So if it has minus, it doesn't mean that we are going to remove the minus. We put the minus there as well. So that means that we have my C is minus. That is a minus 6 over our A is 1. Minus is over 1. Of course, we are going to have minus 6. So that means our alpha plus beta is minus 5 and our alpha beta is minus 6. So the next problem, we have to find 1 over alpha plus 1 over beta. Recall, we derive a formula on how to find alpha plus beta, as well how to find alpha beta, and as well how to find alpha square plus beta square, which means there's no standard formula for 1 over alpha plus 1 over beta, but it's very simple and straightforward. Using the formula, look at it. Now, the first thing, let's find the XCM. If I find the XCM, I know the XCM over alpha beta is going to be what? It's going to be alpha beta, just like if you combine the two together. Now, from here, how many alpha can we get in alpha beta? Meaning alpha can cancel alpha. That means you are going to have alpha beta left. That means I can have beta here plus. Now, how many beta can we have in alpha beta? Of course, beta can cancel beta here. We are going to have alpha here. So alpha times 1 and we have alpha. If I have 2 plus 3, of course, it's the same thing as 3 plus 2. Nothing difference, right? So that means if I have beta plus alpha, it's also the same thing as alpha plus beta. So meaning here, if I have beta plus alpha here, I can just write it as alpha plus beta divided by alpha beta. You can see that we have a formula for this as well. We also have a formula for this. Now, so let's go back to the other one. We have our alpha plus beta to be minus 5. Just substitute. Alpha plus beta is minus 5. And our alpha beta, we have it to be minus 6. So we can see minus can cancel minus. So here we can have 5 all over 6. Are we following? Now, so the next one now, we have to find alpha over beta plus beta over alpha. At the same time, we don't have a standard formula for this alpha over beta plus beta over alpha, but it's just a package, just a math packaging. It's still the same method on how we can approach this, solving it the same way. Let me make use of this, please. We have alpha over beta plus beta over alpha. The first thing is determine your XCM, just like the way you find the XCM earlier. XCM of beta and alpha, that one is still going to be alpha beta, right? Now, how many beta can we get in alpha beta? Beta will cancel beta, we are going to have alpha left, isn't it? So alpha times alpha, that will give us alpha squared plus alpha in alpha beta. Alpha will cancel alpha, we are going to have beta left. Beta times beta, of course, and we have beta squared, isn't it? You can see now, I have from here, I derive alpha squared plus beta squared to be over alpha beta. Now, I have a standard formula. If you recall, we derive alpha squared plus beta earlier. Recall, let me write it for you here. Recall that alpha squared plus beta squared is the same thing as alpha plus beta all squared minus 2 alpha. We have derived that one earlier. Now, let's substitute back to this problem. That means I can have, instead of writing alpha squared plus beta squared, now I write this formula now. That is alpha plus beta all squared minus 2 alpha beta over alpha beta. You can see now we have simplified the problem into these lowest terms, because we have a formula for alpha plus beta, we have a formula for alpha beta as well, we have a formula for alpha beta. So let's just substitute the 3. So can we just write we got our alpha plus beta here to be minus 5 we have our alpha beta to be minus 6. So those are the two values that's how I told you earlier. The most important things under this alpha and beta equation is how can you twist that alpha plus beta, that is using the sum, which is alpha plus beta, as well using the product, which is alpha beta. Now let's go back to that one and substitute the two values. Now, so alpha plus beta, now we have it to be minus 5. Just substitute. That means that we have, so the way we are solving alpha plus beta over alpha, we have it now to be alpha plus beta all squared minus 2 alpha beta over alpha beta. Now, alpha plus beta, we have it to be minus 5 here. So that means I substitute minus 5 squared minus 2. Now, my alpha beta is also minus, that is a minus 6, all divided by alpha beta. So my alpha beta is still remain as minus 6. That is a minus 6. You know, I told you earlier, when you have minus 5 squared means minus 5 times minus 5. So 5 times 5, we have 25. Minus times minus, that's going to be plus. 2 multiplied by 6, that's going to be 12, all divided by minus 6. So 25 plus 12, you know, that one is going to give us 37 all over minus 6. So here you can leave it in fraction. It depends on the result. Either you leave it in fractions or you can leave it in form of what do you call it, mixed fractions. Here I can say this is a minus 6 in 37. Now we have 6 remainder 1 all divided by 6. Or you can even leave your answer in form of a decimal. It depends on how they leave the result in that particular problem you are solving. Just note, when we have alpha plus beta, that one is a minus b over a. If you have alpha beta, that one is a c over a. If you have alpha squared plus beta squared, that one is a alpha plus beta all squared minus 2 alpha beta. And if you have a problem like this, the next thing for us to do, if you don't have a standard formula for it, just simplify until you arrive to this expression we are talking about. If it's some problem, we will be asked to find alpha squared minus beta squared, or we'll be asked to find alpha minus beta all squared. So let's find the derivation of that too as well. Let's find the derivation so that we know how to approach and how to make use of them. Let's say we have maybe I was asked to find alpha minus beta all squared. I will derive it, even if we may also have to find alpha minus beta, or we may have to find alpha cube plus beta cube. It depends on the point, even alpha 4 plus beta 4. So anyone they ask us to just be twisting it is very simple and straightforward. Now let's go back. Let's say we want to find, or maybe I want to find, we still find alpha square minus beta square as well, so that you can know how to approach the problem. Let's say I want to find this. Or here, let's start from the first one here. I want to find alpha square minus beta square. Let's say I want to find this now. You know, if I expand this, expansion of this, of course, is the same thing as alpha plus beta and alpha minus beta. If I expand this, I will get this result, isn't it? If I expand this, I will get this result. You know, you can twist this this method anyhow you like. Either you use in form of in numbers or alphabet. Even if I can even make use of this one, if I have like if I have alpha minus beta, or I can have, okay, let's use that one. You can see that this expression is very simple. If I have let's say we have alpha minus beta all squared, you know, that one simply means alpha minus beta and alpha minus beta. So anyone you use out of the two, either you use the first one or we mix up the second one, you are going to get the same or the same result. Now, if I use, let's say I use this one now, for example. If I expand alpha times alpha, that's going to give me alpha squared, isn't it? Alpha times minus beta, that's going to give us alpha beta. Minus beta times alpha, that's going to give us minus alpha beta. Now, minus times minus, you know, minus times minus is plus. Beta times beta, that's going to give us beta square. You can see I just expand this one to get my result. Alpha times alpha, I have alpha squared. Alpha times minus beta, we have alpha beta. Minus beta times alpha, I have minus alpha beta. Minus times minus is plus. Then beta times beta, we have beta squared. So now here I can have this one to be minus alpha beta all squared is equal to, now let's arrange this one. I can have this one to be alpha squared, then plus beta squared minus alpha beta minus alpha beta. You know, it's like you are adding the two terms together, just like addition. This one can give us minus 2 alpha beta. Now, recall that we have gotten a formula for alpha squared plus beta squared. Recall, let's put it there. Recall that alpha squared plus beta squared. What did we get earlier? Yeah, so we got alpha plus beta all square minus 2 alpha beta. So let's substitute this value into this problem. So that means I can have this one to be alpha minus beta all squared is equal to, instead of writing alpha squared plus beta squared, I will replace it with its own formula, which is alpha plus beta all square minus 2 alpha beta. You can see we have another one here, minus 2 alpha beta. So now I can have this one to be minus alpha minus beta all square is equal to alpha plus beta all square minus 2 alpha beta minus 2 alpha beta minus 2 alpha beta. It's like you are adding them. That's going to give us a minus 4 alpha beta. So now, even if you maybe have to find alpha minus beta, you know, let's say this one is a by squaring both sides. Now, if I square the both sides, that means I can have my alpha minus beta now to be square root of alpha plus beta all square minus 4 alpha beta. You will be asked either you will be asked to find alpha minus beta all squared, or you will be asked to find ordinary alpha minus beta. Even if you will be asked to find alpha square minus beta square, don't worry, I will derive that one for you as well. If you have to find, just like what I mentioned earlier, okay, let's note down this formula. Now what we got for, we derive that alpha minus beta all square is the same thing as alpha plus beta all square minus 4 alpha beta. And if I was asked to find alpha minus beta, we say that one is just find the square root of this one, alpha plus beta all square minus 4 alpha beta. Now, let's assume I was asked to find, let's assume we are asked to find alpha, let's say we have to find alpha square minus beta square. Let's say we have to find alpha square minus beta square. It's just a packaging. Just recall what you have here initially, that you know this one, if I expand this, is nothing but alpha plus beta and alpha beta. You know, this one has its own formula, right? Its own standard formula. As well, we derive this one to also have its own standard formula. You can see we simplify it to the simplest form, standard formula. So we just substitute the two. We know this one is nothing but alpha plus beta. This is nothing but minus b over a. Now this one is just square root of what? Square root of alpha plus beta all square minus 4 alpha beta. You can see I can make use of these two now. If I go back here now, I can say this is nothing but alpha plus beta square root of this one now is alpha plus beta all square minus 4 alpha beta. So let's see one examples. Maybe let's say if y square minus let's say 3y plus 5 equal to 0. They say find. We have to go 1. Let's say, let's based on what we have to find. Let me say I want to find alpha minus beta. So let's say I want to find alpha minus beta all squared, and I want to find alpha minus beta. So by using that, the first thing I will do, I will find my a, just exactly how we approach the first problem. Identify your a, identify your b, at the same time identify your c. So from here, if I go back to that problem, I have y squared minus 3y plus 5 is equal to 0. So from here, I know my a here is 1, right? You can see I even make it easier. My b here is minus 3, and my c is 5. So we have gotten a, b, and c now. So I can substitute these three, making use of to find alpha, beta, and alpha plus beta. So recall the first one. Even the reason why we need to find alpha plus beta and alpha beta is that if you look at the formula for alpha minus beta, so you can see it contains alpha plus beta and alpha beta. Just to make it easier to break it down to the lowest times, so that it will be very convenient for you to perform the operations. So I want to, let's firstly find out alpha plus beta first. I know that one is a minus b over a. So from here, that is a minus, my b now, you can see the minus, the b that we have also have a minus, that is a minus 3 over our a is 1. You know, if two minus follow each other, remember, recall, if minus and minus follow each other, it's going to be positive. So that's going to be 3. Then alpha beta is our c over a. That's going to be, our c here is 5 and our a here is 1. That's going to be 5. So now that means I have my alpha plus beta to be 3 and I have my alpha beta to be 5. Now let me now go back to the problem. Now we are asked to find alpha minus beta whole square. You know, we derive the formula, we prove it that this is nothing but alpha plus beta all squared minus 4 alpha beta, right? So now let's substitute. My alpha plus beta, I have it to be, look at it here, I have it to be 3. That's going to be 3 squared minus 4. My alpha beta, we have it to be what? We have that one to be, my alpha beta, we have it to be 5. So here I can have 3 square. You know, 3 square means 3 times 3. That's going to give us 9 minus 4 times 5. That's going to give us 20. 9 minus 20, we have minus 11. Now, the next questions, we have to find alpha minus beta. You know, it's just like we want to square this value, but let me make it easier. We have that one to be alpha minus beta, that is square root of alpha plus beta all square minus 4 alpha beta. And we have gotten this, that when we find it, we have square root of minus 11. You see, maybe when you are solving the problem, let's say you didn't see a result like minus 11. Recall the complex number. You know, I told you there is nothing like math error here. If you press the calculator for square root of minus 11, you can see that it will show you the math error or syntax error. But don't be worried about that. If you have square root of minus 11, simplify it to 2 times, it means minus 1 times 11, which is nothing but square root of minus 1 times square root of 11. Recall, this is I or j in some cases of this one. You can see that it's simple and also straightforward. So even if we have to find alpha k plus beta, maybe I should derive that one as well to close this chapter. Then we go about how we can find the sum as well, how we can find the product. Let's say we are asked to find alpha k plus beta k. So I promised earlier, you just, it's simple tactics, how we can twist alpha plus beta, which is the sum, and alpha beta, which is the product. How you can choose them, how can we make use of them, either alpha plus beta or alpha beta. The most important thing is for you to recall what does your alpha plus beta means, as well what is your alpha beta, and how you can make use of the simple expansion. Let's say, for example, we want to find the derivative of the derivation of alpha k plus beta k, for example. Let's derive that one here too. We can see that it's simple and very straightforward. Let's say I wanted to prove alpha k plus beta k. Note, you will even be asked to find alpha 4 plus beta 4. So inshallah, we drop our material for you guys so that you can see more explanation on that. Either alpha 4 plus beta 4, alpha 6 plus, no matter how the powers, just make sure that you know how to twist your alpha plus beta as well, and alpha beta. Now let's look at this problem so that we can make use of how we can make use of that. Either alpha k plus beta k, or either what do we call it? Either alpha 4 plus beta 4. Anyhow they pick it out, it's still the same thing. Now let's say I want to find expansion of this. I can break it down that this is the same thing as alpha plus beta and alpha square minus or you know this. If you are talking about alpha k plus beta k, please note the one thing here. If you have alpha k plus beta k, it's not the same thing as alpha plus beta all q. Please note that one, please. It's not the same thing. It's not as if you are going to take it, find the values, find your alpha plus beta. You now say, okay, let me just use the sort method. After getting the value of my alpha plus beta, I will not keep it. If you do that one, let's say, for example, let's say I have my, let me make it easier. Let's say we are solving a problem and we have our alpha plus beta is minus 3. If you have to find alpha, maybe, okay, let's say we have our alpha beta 2 to be 4. and I was asked to find alpha, beta, or phi. This one is straightforward. You just have to substitute the value of your, or any power. You substitute the value of your alpha, beta, and keep it here. I can say 4 raised to the power of 5. But in the case of alpha 5 plus beta 5, please, it's not the same thing as alpha plus beta all. No. This is not the same thing. If you mistakenly put your alpha plus beta, which is -3, and find it fifth, automatically you are going to get another problem. That will lead to another math crime, because we call it math crime. Maybe when you expand the term and you're trying to convert it back, if you don't get the result, that means automatically what you expand is somehow wrong. So please, if you have alpha cube plus beta cube, it's not the same as alpha plus beta whole cube. It's just how we can play with our expansion. So let's see how we can, I told you that how can we write a formula for alpha cube plus beta cube. We said that one the same thing as this one. To make it easier, you can see if I expand this term, of course, I will get back this result. If I expand this term, I will get back this result. If I expand using this to multiply, okay, let's see if you are going to get back this result. Alpha times alpha square, we have alpha cube, alpha times this, and we have minus alpha square beta. This times this, and we have plus alpha beta squared. Beta times this, and we have plus alpha square beta. This times this, and we have minus alpha beta squared. Plus times plus, and we have plus beta times beta, and we have beta cube. Now you can see some terms can eliminate each other here. Alpha cube. Now if you look at this, minus alpha square beta plus alpha square beta eliminate each other, plus alpha beta square minus alpha beta square also eliminate each other. Then we are left with alpha plus beta cube. So now, so we prove that. So let's see how we can have, we are safe here for the first one, because we know that alpha plus beta is have its own standard formula. So now the next thing is how can we expand this one. So I can say this is nothing but alpha plus beta. I can have, recall, let's just arrange this one. The same thing as alpha square plus beta square minus alpha beta. We have a formula for this. Recall that if you have alpha square plus beta square now, is nothing but alpha plus beta all square minus 2 alpha beta. We have done that one earlier. So let's substitute it here now. That means I can have alpha cube plus beta cube is equal to alpha plus beta. Instead of writing this one now, we substitute its own formula, which is alpha plus beta all square minus 2 alpha beta. We have one here also, minus alpha beta. You can see we are trying to simplify the terms. Down here, I can have this one to be alpha plus beta, then alpha plus beta all square minus 4 minus 2 alpha beta minus alpha beta. You do just like a simple addition, that is 3 alpha beta. You can see that we derive this one as well. So after you find the alpha plus beta, just substitute. After it's the same thing here, you square it, then, or let's say I'm solving a problem. I have my alpha plus beta to be -2, or okay, -2, and I have my alpha beta to be 3. So if I substitute the 2 now here, that means I can have alpha cube, this is alpha cube plus beta cube. Now I can have this one to be alpha plus beta is -2, bracket of, we need to just demarcate it to make it easier. Let me use this one, something like this here. Now we have our alpha plus beta to be -2 as well. That is -2 squared. Are we following? So -3. Our alpha beta is also 3. So here I can have this one to be -2. -2 square means -2 times -2, and that's going to be 4 minus 9. Then here I can have -2 minus 4 minus 9, and we have -5. This is bracket. Minus times minus is going to be plus. 2 times 5, we are going to have 10. So the last part we are going to talk about here is how can we solve when we have to find maybe ordinary alpha and ordinary beta. If you recall, we talked about in our previous video, we talked about how we can make use of how we can make use of how to find the root of equation using x squared minus alpha plus beta of x plus alpha beta is equal to 0. So here we are going to need that one, because in some problem you may be asked to find ordinary alpha. You can see you'll be wondering, what is ordinary alpha? Who doesn't have a particular formula? But you have to find its sum and you find its product. So let's talk about that one too as well. Yeah.